For OR inequalities, you want to do this. You want to solve both of them, and then your solution set should include all values that satisfy either one. I want you to make a note here that this is kind of like when we talked yesterday and today about union. Okay, this is like a union of sets, really. But our sets are going to be each separate inequalities number line. That's what we'll be joining. Or unioning. So instead of a list of numbers that we're finding the intersection or union of, it'll be shaded number line solution sets. And so we'll start by doing this example. Take a minute and do the math for each inequality, and then I'll tell you what we're going to do with it, how that OR comes into play in the number line. Okay. You should have x less than -7 or x less than or equal to 2. Who had x greater than -7? Anybody? Let's see, can't fool you. What would have happened if someone put x greater than -7? What did they do wrong? They forgot to flip it when they divided by negative. So now this is not your actual answer, okay? This is just we solved the inequalities. Your answer is going to be the final graph that we put up there on the number line. But even then, I'm not even going to start graphing on it just yet. What I'm going to do instead is take each individual graph, put it under this one, and then we'll talk about comparing them and seeing which pieces of it is our final answer. So for -7 to 2, I'm just going to throw some numbers up on my number line here. -7, blah, 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 numbers. For x less than -7, is that a parenthesis or a bracket? Parenthesis, right? Because it's not included. It's an open circle, and we're replacing open circles with the parentheses. And it's everything to the left of -7. So that's going to be, and I'm putting this underneath because I'm going to compare it with the other one. So this is x less than -7 right there. Okay. And then I'm going to put under that the other graph for x less than or equal to 2. Now that has an equal bar. That means a closed circle, but we're replacing closed circles with the straight brackets. And so at 2, I'm going to put a straight bracket and shade everything less than it. And now we'll talk about the OR. OR is like union. I want to shade on this number line the entire solution set, meaning every single number that satisfies this one or this one. This was the x less than x. So my question for you is this. I have several questions. Does -2 right here satisfy one or the other? Not both of them, just at least one. One or the other? Satisfies one of them, right? So that would work. Does -5 satisfy one or the other? Yeah. So does 2 satisfy one or the other? Does 3? No. 3 doesn't satisfy either one, right? Does -7 satisfy one or the other? It doesn't satisfy the top one, but it is included on the bottom one. And then what about -8? -8 happens to satisfy both of them. So the final solution set of all the numbers that work for one or the other is this straight bracket here and everything to the left. That yellow is my actual answer. for the compound inequality. Each of the reds is the answer to that single inequality, but compound means we're looking at both of them at the same time. Okay. Let's talk about how this would look different if it was an and inequality. So I told you that and, or I'm about to tell you, and is like intersection. Okay, or is like union, and is intersection. It's what they have in common. That would look like only this section where they overlap each other, right? It'd be nothing here, none of this red part. This red part satisfies only the one. But this section where they are on top of each other, where they overlap, that's what they have in common. That's what we would shade if it was and it would look like this. Okay, that's the difference between or and and. And we're going to work with another one so you can get that down. So the yellow was or, which was the original problem, and the blue, or teal, as my 6-year-old would say, she loves teal, is and. All right. Any questions about that? All right. So let's do an and example. I just told you that and is like intersection, because it has to satisfy both. It has to be what they have in common. And right here, make a note. It says, if there is no overlap, your solution is the empty set, if they have nothing in common. So we'll do an example like that. So we have this compound inequality has and. The right one is easy. Do it fast. No pressure. No, with pressure. That's Finding Nemo. Who got x greater than 2/3? Fabulous, fabulous. You flipped your signs, yes? All right. Let's talk about the left one. What don't I like about the left one? It makes me grumpy all day. The fractions, right? So we want to get rid of the denominators. What number do 3 and 6 go into that's bigger than them, or equal to? Sorry. 6, okay. So we're going to multiply both sides by 6. What other numbers could I have used? 12. Absolutely. We're going to do 6. So remember, this is 6 over 1. So when I distribute it through, I'm really multiplying fractions. You go across the top, across the bottom. So this is 12 over 3x minus 6 times 5 on the top over 1 times 6 on the bottom. And what is 0 times 6? 0, right? Sometimes that really simple stuff trips people up. And then you simplify these fractions, giving you 4x minus 5 less than or equal to 0. Take a second and solve that. So we got rid of the fractions just to get more fractions, right? 4x less than or equal to 5, divide both sides by 4. X is less than or equal to 5/4, and x is greater than 2/3. So that's not my answer, right? That's just, I just solved them. Now I'm going to graph their solution set. I think it's easier to, when I go to graph, convert these to decimals. So 5/4 is 1 1/4, and 2/3 is 0.6 repeating. And since those are decimals and they're so close together, when I go put my numbers on my number line, I'm going to go by halves. 1, 1 1/2, 2, 2 1/2, 3, because it'll give my numbers some room to breathe when I go to graph. So I need 0.6 as a boundary. I need 1.25. So what I'm going to do is 0, and then that's 0.5, that's 1, that's 1.5, and that's 2. So for this first one, x less than or equal to 1.25, that's going to get a straight bracket because of the equal bar. And it's going to be everything to the left of 1.25. So that is here, halfway between 1 and 1.5. So that's x less than or equal to 5/4 right there. And then x greater than 0.6. So that's a little bit bigger than 0.5. So here's my 0.5. I'm just going to go a little bit to the right with a parenthesis and go out that way. And I want you to take a minute and you put down on the main number line what you think the intersection of those two is. And means what satisfies one and the other at the same time. So take a second and you try that. Let's talk real quick about this. So some questions I had is, what is the answer supposed to be looking like? Is it set notation, interval notation? Like, what is it that you're looking for? What I'm looking for is just the graph for this problem. Just the graph of the solution set. And I want it specifically to be what those two number lines, the green ones, had in common. Where do they overlap? And they overlap just in this little section right here. And so here's what that would look like on the number line part. It looks like a parenthesis above this one, this bracket here, and then everything in the middle. That yellow stuff, that's your answer, okay? And the way you could know that is, it's not asking you for set notation, it's not asking you for interval notation, it's just asking you for the graph of the solution set. Mustard, relish, ketchup, right? It's like a perfect hot stuff. Does anybody have a question or need this up anymore? All right. This is a lot of words, but I think this is actually the easiest part of the whole lesson. This is when your compound inequality is written as one statement. Now this one right here, these that we've already done was two things with an and or an or. This right here is talking about when it looks like that, just one long statement. And if I were to tell you, and let's kind of back up a little bit. Let's say this 2 wasn't even here. And I said, solve that inequality. What would you do? How would you start? Add 4, divide by 3, right? That's exactly what you're going to do here. You just have an additional side. You have a left side. Now you have a left and a middle and a right. And whatever you would do to get x by itself, you're going to do to all 3 of those sides. And that's all that these words basically are telling you. And reminding you that if you're multiplying or dividing by a negative, you flip the signs. So let's look at that. So you told me that if the 2 wasn't there at all, we would start by adding 4 to both sides. That's correct. We're going to do that now. To the left, to the left, to the middle, and to the right. Okay. So that's 6 less than 3x less than or equal to 23. What next? What did you tell me to do before? Divide by 3. You're going to do that in how many places? All 3 places. So I have 2 less than x less than or equal to 23 thirds. And I'm going to convert 23 thirds to a fraction to make it easier to graph. 3 goes into 21 7 times with a remainder of 2. And on this graph, there is no comparing one number line to another and then figuring out how they go together. Because this is telling you, I want all the x's between 2 and 7 2/3. And so you just put your boundaries up there. So here's 2. I'm going to go up to 8. So 2 is my left boundary. Does it get a parenthesis or a bracket? The 2. Parenthesis, right? What about the 7 2/3? Bracket. So here for 2, 7 2/3 with a bracket, and I want all the values in between them. Okay? So I feel like those are the easiest ones on the whole lesson. So this is symbol notation. That's a picture, right, of the solution set. Any questions about that one? There's one more problem on your notes, but I want to skip it and do this one instead. The last problem is just like this, only it's got a decimal, and you'll have to divide by a negative, but I feel like you can handle that, and I'd rather spend class time doing one of the little bit harder ones because I feel like that's an easier one. So this happens to be the first problem on your homework, so I'm going to give you your homework, but don't pack up yet. We're still doing this one together. It's the first problem. I want you to try it on your homework. Yeah? What did you come up with as a solution on the number line? Anybody want to share? It's a little bit different than what we've talked about. Anybody comfortable enough to share what they feel like it is? No? Well, let's look at the individual number lines, or the individual graphs. X less than or equal to 6 is this. X greater than 3 is this. And or means that on the actual number line, that's for our answer, I need to shade in every single number that satisfies the top one or the bottom one. What kind of numbers is that? All of them, right? All of them. Because any number here satisfies this top one. Any number here satisfies both of them. Any number here satisfies that one. And so this happens to be all real numbers. And here's how you would shade in for your final answer. It's this entire thing. Let's talk real quickly about